Just as a recap, we've already gone through our preparatory activity. You've done some reading on the difference between experts and novices and met this idea of the learning objective. Now we're going to go over some examples and evaluate them for quality. Then we'll come up with some tasks, some perspective shifts, and then you will create a learning objective for a lesson that you may actually teach. On to the examples. So let's say you were asked to teach multiplication to students who'd never seen it before. Let's go through 4 potential learning objectives, from what I would say is worst to best. First, students will understand multiplication. To me, this is a useless learning objective. It uses this vague term, understand, and offers me no insight into what students are actually going to do with their knowledge. This will not help me inform any of the design decisions I go on to make later. What about this? Students will correctly multiply 2 one-digit numbers. This is definitely better. It does tell me the scope of the task, 2 one-digit numbers, that the students will be asked to perform. And that task seems reasonable for where the students are at if they're just learning multiplication, and it's aligned to something experts do. They actually do correctly multiply 2 one-digit numbers when they need to. But it doesn't give me any insight into what's going on in the student's brain. For all I know, students may be using calculators to do this. What's actually changing in their mind that allows them to multiply 2 one-digit numbers? Let's look at another learning objective. Students see the multiplication table as a useful tool, and they solve a certain number of problems in a certain amount of time, with a certain amount of accuracy. You know, you could actually argue that this is worse than the previous learning objective. While this last one didn't give me any insight into what the student's new perspective would be, this one does. They see the multiplication table as a useful tool, but it actually specifically is articulating a terrible perspective to have. Yes, maybe it is a useful tool, but that's not what we want to change in their brain. We want them to see numbers differently. We want to build expertise. If I were using this objective to inform design decisions, I'd probably go down the route of memorization. This is not building a schema that will continue to be useful in the future. In fact, it's building a schema more like this or this, about how numbers interact, rather than a more deep, rich network of connections, which is what we want to create. So let's go on to the 4th learning objective. Here, students are seeing the multiplication symbol as an instruction to repeat. They solve one-digit multiplication problems, so same task as before, but now it's even more specific. They're drawing grids of dots. So 3 times 2 would be 2 rows of 3 dots. And then the students are counting the number of dots. For a student who is just learning how to multiply, this seems like a great learning objective. It articulates a very clear task. And even though experts don't actually count dots, it's building a schema that is consistent with how experts see multiplication. It really is an instruction to repeat, and this is a great way to start driving that point home. Additionally, whereas with memorization, these students would have been out of luck if asked to solve 272 times 49, in theory, students could still draw a very big grid of dots. But by then, they'll probably be ready for a different approach, which will be a perfect opportunity to teach them the standard algorithm for multiplying larger numbers. So take a look at these 4 different options for a learning objective on a multiplication lesson. What can we generalize? What are the qualities of a good learning objective? Take a minute to think about it for yourself, and then I'll show you what I think makes for a great learning objective in general.